Should be in the chat, 6720.
I went to take the pre-quiz and it asked for a password.
Okay, who's Rachel? Yeah, I emailed you back. I gave you the password. I sent it to you.
Oh, okay.
Yeah.
Okay.
In the future, though, I would need your proctor. I would send the password to your proctor, not to you directly.
Okay.
Okay.
Okay. So for the pre-quiz, would I need to go to the library to take that or
Yep.
okay.
Okay, it says it's recording, so we'll see. Okay. I don't know if I've got it figured out. I'm trying. I wonder if I could change this. All right. I think I'm gonna go ahead and get started. So remember, ideally your video is on. I'm gonna go ahead and mute everyone, I think. Yeah. Until something needs to be answered. Okay. Um, Today's lesson is really short. I think it is. It's I'm sorry, I'm like all over the place today. Forgive me. Let's see, share screen. Okay. So let's take this. Let me see the chat. There we go. Okay. So today is simply um, identifying functions using graphs. Um, she calls these toolkit functions. I want you to like cross that out in big giant letters. It's not the phrase we use. It's parent functions. I thought I'd fixed all of them, but I just noticed it in the objective. These are parent functions. So they're called a parent function because every graph that we have, lines, parabolas, anything like that that we're going to do in this class, all come from an original. So we call those originals the parent functions. All right, graphs help us a lot as far as being able to identify. Just to recall from last lesson that graphs have ordered pairs, x's and y's. X is your input, y is your output. So x is your domain, and y represents something called the range. Okay, so this phrase that's written here, the graph of the function is the set of all points x and y that satisfies the equation y equals f of x. So it's every point that makes your rule work. So when you plug in an x, you get out a y. Okay, it's going to be all of those points. So f of 0, we'd find 0 on our graph. 0 is here at the origin. I'm going to go up until I hit my graph, and I can see it right there. That y coordinate is what? Yeah, you can put it in the chat. That would be easiest that way I can read it. Perfect. All right. Follow the same thing with f of 6. Good. So f6, as it goes slow, there we go. 1, 2, 3, 4, 5, 6. Yep, there's 6. That y coordinate is a 1. Oh gosh, sorry. Startled me. Okay. Also in the last set of notes, we talked about something called the vertical line test. So if a vertical line goes through the graph in more than one location, it is not a function. We saw these pictures last time. All right, I can draw a vertical line anywhere on here. And it's not going to hit the graph more than once. Okay, so this one is a function because it passes the vertical line test. Whereas this little guy, draw a vertical line in a few spots, and I noticed that it's going to hit the graph twice, a lot of times. Not a function. Because it fails the vertical line test. And we saw this last picture as well. This is an ellipse, and it also fails the vertical line test. Because with the exception of a couple of points, it's going to go through the graph more than once. So it fails the vertical line test. Okay, this is all stuff we covered Tuesday. All right, so I want to give you guys maybe a minute or so. I'm going to label this one as A, this one as B, and this one as C. Okay, in the chat, I want you to tell me which of these three graphs represents a function. All right, I'm seeing lots of A's and B's, seeing primarily B's, which, yes, B is 100% a function. Okay, it very clearly passes the vertical line test. I'm only going to hit that line once. The hard one is this one, because while it doesn't look like it, if you draw a vertical line anywhere on there, it's only going to hit the graph once. That's not a bright enough line. Let's do this one. I'm only going to hit the graph once. It doesn't look like it, 'cause especially when we get over here to the sides. But if you zoom in enough, it only hits once. Okay, so it's going to be A and B. And I'm glad none of you put C. C fails the vertical line test in a big way. It's a circle. Okay. Okay, now we've done vertical line test. This is weird. I don't like this. Can I minimize that? Sorry. I was just see if I can like not have my face in there. No, okay, I'm so sorry. I cannot. All right, so my face is gonna be in that picture. We love that. Okay. All right, we've done vertical line test. Now we're gonna do something called the horizontal line test. So first things first, the graph has to pass the vertical line test, or it's not a function. But then we can clarify a little bit more with something called a one-to-one function. Okay, a function, things being slow. A function has no repeating x's. One-to-one has no repeating x's and no repeating y's. Okay. So if I have a function, something like f of x equals x squared, I plug in -3. I'm going to find f of -3. Okay, that means we take that -3, we're going to replace that x. So that's -3 squared, which is 9. Let's say I plug in the +3. Okay, we also get 9 there as well. All right, so that's a repeating y, which means x squared is not 1-to-1. So 1-to-1 has 1x to 1y. None of the x's repeat, none of the y's repeat. If I've got a function like g of x equals x, though, like that, any x I plug in, okay, I'm going to get a different value. So let's say I plug in a 1. Well, g of x would be 1. Okay, what if I plug in a 2? G of x would be a 2. So if I make a little bit of a t-chart here, plug in a 1, we got out of 1. Plug in a 2, we got out of 2. So far, my x's don't repeat and my y's don't repeat, which means g of x equals x is 1-to-1. And no repeating x's, no repeating y's. So that brings us into our second test, which is the horizontal line test. So it has to pass the vertical for it to be a function. And then for 1-to-1, it has to pass horizontal. Okay. So let's just look at this first one real quick. The first thing I want to check is it a function to begin with? If it's not a function, then 1-to-1 doesn't matter. All right, so I'm checking for the vertical line test. Okay, is this one going to pass the vertical line test? Good. Lots of yeses, and that's right. This does pass the vertical line test. But now I need to decide if it's 1-to-1. So now we're looking at horizontal line test. So if I draw a horizontal line and it only hits the graph one at a time, it's 1-to-1. So this is a yes. Okay, in the chat, tell me if this one, first it's a function, then 1-to-1. So I see is a function, lots of that, and then 1-to-1. Good. Perfect. Let's try this one. Go. It's not even a function to begin with. So if it's not a function, one-to-one doesn't matter. It would fail that test anyway, but it's still not a function. Okay. Next one. Is it a function? And is it one-to-one? All right. I think this one is messing with some of you guys a little bit. Um, so this is a function, and I know it's so hard to tell right here. So I'm going to put a similar graph in the Desmos graphing calculator and zoom in a little bit. Can I just get a new graph? Sorry. Let's see. Um, nope. Okay. No, no, no. Oh my gosh. Let's go back there. Functions. So you can do a lot in Desmos. I'm just gonna find the right one. There it is. Okay, so similar graph, right? All right, and where I'm seeing most people kind of say it fails is right there in the middle. So right at that 0, 0. All right, so if I continue to zoom in on that 0, 0. All right, kind of hard to tell, but I don't know if you can see down towards the bottom, kind of towards that negative point 0, 1 and up towards the top. It's still slightly tilted. All right, so this passes the vertical line test. Barely, but it does pass. And so in that case, now that it's passed the vertical line test, does it also pass the horizontal line test? Go. So this is 1-to-1. All right, so here in about 10 minutes, the attendance code is going to close. So I'm going to put it here one more time. If you haven't done attendance, it's in the chat. Okay, let's flip the page. Guys, we are literally almost done. So, this is going to be a really good resource for you. As far as, let's see. Yeah, okay. Kind of having a chart of the different types of functions you're going to see. All right, so for this class, we're going to see 9. Okay. First type we're going to see is called a constant function. Okay, I'm using some technical vocabulary here. It says f of x equals c. C is a constant. So I want you to write under constant, this is a number without a variable. Okay, this means that every y value is the same. F of x equals c is always, I'm giving you all kinds of details here, is always a horizontal line. always. So in the graph that you see here, I can see that the y value is always 2. It's never going up. It's never going down. That's why it's called a constant function. It doesn't change. It's always flat. So the equation for this line would be y equals 2, because y is always 2. Our next one is the linear function. She calls it the identity function, but it's linear. All of our straight lines, with the exception of our constant and our vertical lines, come from this graph. Right. And the key feature. So I want you to circle that X. In a linear function, the highest degree is a 1. All right, so in this little bitty X, okay, it doesn't look like there's an exponent, but there's always an understood one, and that is a 1. So you're not going to see any exponents other than the understood exponent 1. Okay, so it could be something as weird, random as, I'm just making this up. Hey, it's all over the place, but I'm looking at this X. I have just the one X, and its understood exponent is a 1. It's linear. Our next one is probably one of the more recognizable graphs. All right, this is the absolute value. Okay, absolute value is a V-shaped graph. So taking it back a little bit, absolute value means distance from 0, and distance is always positive. Okay, that's why you don't see anything underneath this x-axis. It's all up above. It's all where the y's are positive. All right, because even if you run backwards, you're still running a positive distance. Okay, if you go drive in reverse, you're still going a positive distance. Negative distances are not a thing. Distance is always positive. Fourth one, this is called a quadratic. Okay, and it's quadratic. You know a function is quadratic because its highest exponent would be a 2. And it's called a quadratic because when you say an x in the exponent 2, we say it's squared, and a square has 4 sides. So quadratic. Quad for 4. Okay, this type of graph is called a parabola. We'll hit that again in a later unit, but that graph is called a parabola. So anything that has the highest exponent of 2 would be considered quadratic. So if I've got something like that, I'm looking at the highest exponent. There's 2 x's. Great. But the highest exponent in those 2 x's is the 2. It's quadratic. Make sense? Let's go down here. Cubic function. Okay, highest degree, highest exponent is a 3. All right, this one can come in a couple of different forms. This is not the only graph for a cubic function. You can see, you might see loops, like hills and valleys, like that. But if you look at the exponent, the highest degree is a 3. Okay, so I could have mixed up functions. I could have x squared minus 4x cubed. Let's call it that. It's not even in the right order, but my highest exponent is a 3. It's considered cubic. Always look at the highest exponent. All right. Rational reciprocal. All right. This one's recognizable because it has a variable in the denominator. That's the first clue, that there's a variable in the denominator. And that variable in the denominator is linear. Okay, which means its exponent is a 1. Okay, so the primary title that we call this falls under a big broad group of things. This is your reciprocal function. All right, let's flip the page. We're almost done. Rational squared function. Variable in the denominator. And its highest degree is a 2. So the thing these two have in common, because they're both considered rational functions, is they have this thing called a vertical asymptote. So a vertical asymptote, let's make that smaller, is kind of an understood vertical line that these little pieces of the graph get really close to, but they don't cross. So vertical asymptote. Asymptote is one of those weird words that doesn't look like how it sounds. I have to sound it out every time I write it down. So every time, like, okay. Understood, which means it's there, but it's not. That the graph approaches. But doesn't cross. So it's going to get really annoyingly close to that vertical asymptote, but it's never going to cross that vertical asymptote. Okay. Square root function. All right. The characteristic of a square root function in the equation itself is that we have that square root. Okay, and this little guy right here that tells you that x is greater than or equal to 0, it's saying that the x can't be negative. All right, so the stuff under the radical, whatever's under there, can't be negative. All right, wait, it ends up with something called imaginaries, and you don't need that right now. That's a future problem, not a now problem. Yeah. The other key characteristic is that there's an endpoint. Okay, other graphs keep going. That has a very clear endpoint. Because if you go any further to the left, you get the imaginaries. We don't want the imaginaries. And your last one is the cube root function. This one's recognizable because it looks like a flat S. Okay, we did this a minute ago with the one-to-one and the function. And its equation looks like the square root, but it has a little 3 instead. All right, so guys, that's it for today. Are there any questions? All right, guys, make sure that you go take that pre-test. It's going to score it. You're not going to see your score right away. You'll see your score in Blackboard, but as soon as everyone's done, I'm going to go in and make it all full credit. Okay? So don't panic. This is not hurting you. I need a spot check. All right, and TCC is asking for that same spot check. Okay? All right, to my essentials students, let's meet in about 5 minutes. So my clock says 6:02, so let's say 6:07. And then we can get it done early. Everybody good with that? Awesome. Um, if you weren't able to get into the attendance code, Zoom does save entries so I can see who's come in and who's left and kind of how long they were in there. So if you weren't able to, I can go back and verify from that. It's just 17 steps instead of the 2. Okay. All right. Essentials, I'll see you in, yes, you do the pre-quiz at a testing center. Okay, I've already heard from a couple students who are outside the 30-mile radius. If you are one of those students who are outside of 30 miles from a testing center, then I need to know where you're testing and I need to know the name of your proctor and their contact info because I'll send them your information, like passwords and like required supplies and all that stuff. Okay, yes, most of you are doing this at the testing center, right? If you live in like Southwest Oklahoma, no, you're not doing it at a TCC testing center. We don't exist down there. And I know Rachel Mulholland, you're in Tahlequah, so that's not within 30 miles here. So if you're in 30 miles radius from any TCC testing center, that's West Campus, Northeast, Southeast, Metro, any of those, you take it at a TCC testing center. Okay, they're requiring that. Okay?
And we have till the end of Tuesday to
Yes.
get it done. Sorry.
Yeah, no, you're good. Yes, you would have until Tuesday. Just to allow you guys the travel time to get there. Okay? All right. I will see you guys all on Tuesday, Essentials. I will see you in, let's do 4 minutes now. Let's do 6:08 because I've been talking. Okay? All right. Have a good evening.